Welcome children. Today I am going to teach class 10 maths chapter 1 real numbers. Before going to know the real numbers, we must know natural numbers, whole numbers, integers, rational numbers and irrational numbers. Let us see one by one. This is a number line. Right from 0, all numbers are positive numbers. So these numbers are natural numbers. Natural numbers are the positive integer or non-negative integer which starts from 1 and ends at infinity, such as 1, 2, 3 and numbers are going on. Next, whole numbers. Whole number is a collection of natural numbers and 0. It is represented by W. This is a set of numbers are 0, 1, 2, 3 and going on. Next, integers. It is a special set of numbers comprising 0, positive numbers and negative numbers. It is represented by Z. Rational numbers. Rational numbers are numbers that can be written in the form of P by Q, where P and Q are integers and Q does not equal to 0. Rational numbers have no common factor except 1 and Q is positive. Examples are 1 by 2, 1 by 4, 5 by 2. These are the examples of some of the examples of rational number. The decimal expansion of rational number either terminates after a finite number of digits or repeat the same finite sequence of digits over and over. Let us see one example. One by 2. Now I am going to divide 1 by 2. 5 2s are 10, 0. The decimal expansion of 1 by 2 is 0.5. And I give one more example, 1 by 4. So I am going to divide 1 by 4. So put a decimal point. You can add 1 0. 4 2s are 8. Remainder 2. Here decimal point is there. So you can add 1 0. 5 4s are 20. So decimal expansion of 1 by 4 is 0.25. One more example I am going to give. 14 by 11. I am going to divide 14 by 11. 1 11 is 11. Remaining 3. So here I put decimal point. Add 1 0. 2 11s are 22. Remainder 8. Here already I put decimal point, so I can add 0. 7 11s are 77. Remainder 3. So here I put decimal point. You can add 0. 30. 2 11s 22. Remainder 8. Again 0. 7. 77. So numbers are going on. Here 2 digits are repeating. So you can write 1.27, 27, 27. It's going on. You can write 1.27 bar. So decimal expansion of rational number terminates or it is repeating. It is non-terminating and repeating. Rational numbers we can write in the form of P by Q, and irrational numbers we cannot be expressed as a ratio of two integers. The decimal expansion of irrational numbers neither terminating nor recurring. Examples are root 2. So 1.4121, the numbers are going on. The numbers are not terminating and not recurring. And pi also the examples of irrational numbers. So real numbers are numbers that have both rational and irrational numbers. It is represented by the letter R. It indicates that every real number is either a rational number or irrational number. fundamental theorem of arithmetic. This theorem, otherwise called it as unique factorization theorem or unique prime factorization theorem. Before going to see the theorem, we must know some of the definitions. First one is a prime number, the number that can be divided exactly by 1 and itself. These are the examples of prime numbers: 5, 7, 11, etc. 5 we can divide it by 1 and number itself. These numbers are divided by 1 and number itself. And 12, can we say 12 is a prime number? No, we cannot say 12 is a prime number. Why? Because 12 has a 12 we can divide it by 2, 3, 6 and 1. 12 we cannot say prime number. Next one is a factor. A factor is a number that divides another number leaving no remainder. Examples: 3 is a factor of 6. We can divide 6 by 3, we get no remainder. And if you divide 6 by 2, we get no remainder. So we can say 2 and 3 are the factor of number 6. Next, prime factorization. Prime factorization is finding prime numbers multiplied together to make the original number. 12 we can write the product of these prime numbers: 2, 3 and 2. Co-prime numbers. Co-prime numbers are pairs of numbers that don't have any common factor other than 1. Co-prime numbers need not be prime number always. Examples: 3 and 5. These numbers are co-prime numbers because it has a common factor 1. And 14 and 15. So these numbers are called co-prime numbers because in both the numbers we have a common factor 1. Next one is a composite number. Composite numbers are numbers that have more than 2 factors. For example, 15 is a composite number. The factors of 15s are 3, 5, 1. The numbers which have more than 2 factors, that number we can say a composite number. So 15 is a composite number. Why? Because it has more than 2 factors. Fundamental theorem of arithmetic. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factor occurs. Example: 24. We can take 24. 24 is a composite number. Now I am going to take a prime factorization of this number 24. So you can use only prime numbers. 2 times 1 2 is 2, 2 2s are 4, 2 times 6 2 is 12, 2 times 3 2s are 6, 3 times 1 3 is 3. So 24 we can write as a product of prime numbers. 24 is equal to 2 into 2 into 2 into 3. If you change the order also, the value does not change. You can write 3 into 2 into 2 into 2. And it's a unique. Unique means fixed value. You will get the fixed value.